Okay, so let's get started. So we're going to talk about something called property-based testing. So before we talk about this property-based testing, we're going to take a few minutes to just remind ourselves of what is a unit test. So if you take basically any tutorial or any textbook that talks about unit tests, you're going to find these three words: given, when, and then. And that makes sense because basically these three words, they describe the structure of a unit test, which is given some state, when I perform this action, then
let's break it up a second. I think there's some microphone in the podium. Let's see if we can fix it, yeah.
Yeah.
Okay, this is it.
Okay. I mean, yes, if it's like distracting, it will be better that we take care of it right now. Okay. Cool. Cool. Sounds better. Cool. So, we were saying, given some state, when I perform this action, then I expect that result. And indeed, when we write tests for our app, we tend to follow this structure. We are going to say, okay, given this valid set of data, when I run my business logic on this data, then I expect some results that are the correct output of my business logic. And we are also going to do the same thing for invalid data, in which case we are going to expect that there is an error that happens and that the error is handled properly. So this is how we write unit tests. And basically, if we try to represent it like as a Venn diagram, we could say that there are valid data in green, there is invalid data in red, and what we do when we write our test is that we pick points in these sets, and we write code that runs our code, our business logic, and we make sure that everything is going fine. And this is cool, but on this diagram, there is one part that is very important that we are missing out when we write tests like this. It's this line, and this line is the edge cases. Because as you all know, edge cases are where the bugs happen, and edge cases are also the part of the data of the app that are sometimes hard to understand. Sometimes when we have a bug in production, we are surprised when we see the data that produced the bug. So our classic unit tests, they are awesome because they are great at catching regression in our code because they run on the same data every time. But they will not allow us to learn anything new. They will not allow us to learn that a particular data set could crash our app. And the question that we might be asking ourselves is, could tests actually help us discover edge cases? And as it turns out, the answer is yes. And behind this, there is a very simple idea, is that when you write your test, your classic unit test, you set the data is fixed, and then you check that some properties are respected. And in order to have tests that help you find edge cases, you just need to reverse it. You just need to say, okay, I'm going to fix a set of properties that should always hold true for my code, and then I'm going to try and find data that breaks those properties, and when I do, and if I do, I will have found a bug in my application, and I will have learned a new data set that breaks my application. And I will be able to take action on this set in order to fix the issue. So let's look at a concrete example in order to make sense of this. So let's consider this function from the Swift standard libraries. So the function reversed that's defined on arrays. So this function is pretty straightforward. It takes an array and it reverses the order of the element inside. How could we define a property over such a function? Well, we can start by doing it with natural language. We could say, okay, if an array is reversed twice, then the result is equal to the input. And it makes sense because when you have an array, you reverse it twice, you get back to where you started. So that's good. We can even improve it by writing it still in natural language, but more in a mathematical way, saying any array reversed twice must be equal to itself. And if we want to go one step beyond, we can use first order logic and write it like this. It's the same thing we say for any array. If I call reverse twice on the array, then I must have the result must be equal to the initial input. And so how can we implement this in code, such property? We can do it with functional programming. We can write a function like this. And this function, what's really cool is that it matches really well our property because The variables in the property are the arguments of the function. And the property itself, it's a Boolean expression that's being evaluated by the function. So this function, it implements the property that if I reverse twice an array, I must get the same result than the input. Okay. So now, property-based testing, how does it actually work? Well, for our classic unit test, we had the three words given, when, and then. And for property-based testing, it's kind of the same thing. We have three terms. It's for, any, such that, and property. And they work like this. We say for any input value x, y, z, such that a precondition is satisfied, then a property must be true. So let's try and apply it to our example. So it looks like this. We say for any input value, which is an array, we don't have a precondition because it works for every array. If I call reverse twice on my array, basically I must get the same array. So array.reverse.reverse equal array must be always true. And then how can we implement this kind of test? How can we have like a framework that will actually go and try to find values that break the properties if any exist? So there is a framework that's called SwiftCheck. It's an open source framework, and it's what we are going to use to write property-based tests. So if some of you know Haskell by any chance, there is a framework called QuickCheck in Haskell, and SwiftCheck is a Swift port of QuickCheck. And it works by following a very simple set of rules. What it's going to do is that we are going to write properties, and the framework is going to test those properties by feeding them some random input values. And then if the property were to fail, meaning like if we generated a set of values that make our code basically crash, produce a bug, the framework is going to try and shrink the value as much as possible. The idea is that if we made the property fail using, for instance, an array that is 10,000 elements, it doesn't make sense to produce a log with 10,000 element arrays, so we are going to try and reduce the array as much as possible. The idea is that the framework will try to give you the smallest counterexample of your property. This way you will have a data set that is very actionable, meaning that we can understand these data sets and we can run our code on it and understand basically what went wrong. And so the framework is going to tell you either, okay, your property is valid, it's held true for every random value I try to feed it, so it looks like your code is okay, or it's going to return the smallest counterexample of where your code went wrong. So SwiftCheck, it works basically by this protocol which is called arbitrary, and this protocol has two requirements. You need to have a generator in order to generate random values, and you need to have a shrink function that is going to let you shrink a big data to a smaller data. And of course, SwiftCheck already implements this protocol for all the basic types like int, string, etc. So this is actually how it works when you implement a property using SwiftCheck. So you can see that there is a function called property. We give the name of our test, of our property. So here is a simple test of reversing an array. And then you can see that there is some kind of a DSL-like syntax. And we say, okay, so for all array, I want to test that the property, if I reverse my array twice, I get back to the same array. And basically what the framework is going to do is that it's going to run this property by feeding it random arrays. And if there were to be a bug, we are going to hope that one of these random value is going to make the program fail. And it was a very simple example where we can, of course, do it with more complex properties. For instance, if we want to test this time that the elements of the array are like correctly being reversed, we can write a property like this. We say, okay, for any input values, an array and an integer, such that the array is not empty and the integer is an index in the range of the array. We want to check that if we reverse the array and we check for the index, then if we go look at the symmetric position in the initial array, we should find the same element, meaning that the array has been correctly reversed. And we can implement this using SwiftCheck. So I'm going to walk you through it because there is more code. So we write our property. We say, okay, for any array, if the array is not empty, then I take a random index in the range of the array. And then I'm going to test that for this index, if I reverse the array and I look up at the index, and then I look up at the symmetric position in the original array, I indeed get the right element. And then this test is going to get basically executed several times. And the idea is that if there is a bug, we are going to, at some point, it's like very likely that we will find a data set that is going to make the property fail. Of course, since we are testing a function from the standard library, we can hope that it works well, and we are actually not going to find bugs when we run this test. But we can also try to catch real bugs. So let's take a real-world situation. Let's say we are asked to validate email addresses. So we are developers, we are lazy, so we are not going to come up with code. We are going to ask Google to do it for us. So we ask Google, what could be a nice regex in order to validate email addresses? And we got this result. It looks kind of legit, but we actually have no idea whether or not it works. We would like to have a test that gives us confidence of whether or not it works before we ship it in our app. So how could we test this regex? We start by encapsulating it within a function that is going to have a nice signature. It takes a string, which is an email address, and returns a Boolean to tell you whether or not it's a valid email. So pretty straightforward. And then we are going to create a generator that is going to generate random valid email addresses. So we start by basic building blocks, so a generator for uppercase character, same thing for lowercase character, numerical characters, special characters. Then using this, we generate what is called the local part of the email, so it's everything that's before the @ sign, by saying, well, a character in this local part of the email, it can be either an upper, lowercase, numeric, or special character. It cannot be empty, because that part of the email is not allowed to be empty. It cannot end with a dot, because that's also forbidden in an email address. And finally, since we are getting an array of characters, we map it to a string, because it's a type that's much more easy to manipulate. Then we do the same thing in order to generate the host name and the extension. We put it all together using the glue function. We say, OK, when we are going to run our test, we want some arguments. We don't want to have an email that is bigger than 10 characters, because you will see that we actually don't need to go that much to find a bug. And then we write our property. We say, OK, we want to test that for any email that we generated using our generator, which are valid emails, we want to test that the regex actually returns yes, meaning that every valid email that we generated, our regex recognizes it indeed as a valid email. And we say we're not going to try to shrink the value, because since it's a string, if we shrink it by removing characters, it won't be a valid email again. So in this case, we say no shrinking. And if we run this test, we're going to see this. And we're going to see that after only like 2 iterations, we found the bug, because it turns out that this email address, which is pipe@o.az, it's a valid email address. It can exist, but the regex that we found on the internet does not recognize it as a valid email. So what's kind of cool is that we have found a bug, we have found an edge case that we probably would have never thought of before, and actually this could break our app, because since this is a valid email address, someone might want to fit it into our app, and it's important that our app does not refuse such an email, especially since we are now seeing systems like privacy system that hide your email behind an alias. If we refuse email that just don't look like human-readable email but are still valid email, we could lose customers. So it's actually very interesting in a business perspective to be able to catch this bug before we ship our code to production. And as you can see, the bug was found very fast, because it only needed to generate 2 values to find it. So we managed to catch a bug. That's pretty cool. We could also ask ourselves the question, we tested for valid emails, could we also test for invalid emails? As it turned out, the answer is actually no, it's not possible, because if you think about it, in order to generate invalid email, you would need a precondition that would tell you that this email is indeed invalid, and this is exactly what we are trying to test in the first place. So in such a case, the only way to write a good test for invalid emails is the given when then approach, where we say, OK, I know that this is an invalid email, I have set it, and I want to test that my regex indeed says no. And classic unit tests and property-based tests, they are not mutually exclusive. Actually, you can mix them together pretty well. For instance, consider this function, which is going to compute the average of an array of numbers. We could write a test that is based on data. So we say, okay, for this array, if I compute the average, I want to check that the result is indeed this value that I know to be the correct value. But we could also write property-based checks that are going to test properties of the average. For instance, for an average, there is something that the average of product is equal to the product of the average. So we can write a property-based test that is going to check that this property holds true. We can do the same thing for the fact that the average of sum is the sum of the average. And as you can see, when we mix both approaches, we get a very interesting code coverage, test coverage, because we are testing our code in different ways and in ways that basically complement each other. But you might be thinking, okay, how do I use this in my app? Because we're talking about properties, and the properties, when you're talking about computing an average or about reversing arrays, it's easy to find properties, but in our app, we have business requirements, and business requirements are messy, and it's much harder to find properties, and you would be absolutely right to think so. Properties are easy to define at a lower level, but when we get to business requirements, it's more complicated. However, you could consider a property that is extremely easy, extremely trivial, is that you have a random input, you just run your business logic, and you return true. So this might seem rightfully very trivial, but actually it performs two very powerful assertions, because it's going to check that the function myBusinessLogic does return, meaning there is no infinite loop or there is no Stack Overflow, and it's going to check also that this function doesn't crash. And actually, these are true properties that we want to have in our production app. We want our app in production to not halt and not crash. So actually, for something so trivial, it's pretty powerful, because you could write some code that would just run your business logic on random input and just check that it doesn't crash and doesn't basically stuck your app in an infinite loop, and you already have some nice coverage that didn't cost you a lot. And if the architecture of your app permits it, you could even have a code generation tool write this kind of code, because it's code that is very boilerplate, so you can even get it like for an extremely small cost. And you can also find other kind of trivial properties. For instance, for UI testing is something that is often costly to do, but you can think of very simple things, like in most screen, it doesn't make sense for two views to overlap. Well, this is a property that is maybe a bit trivial, but still useful, and it could be very easily implemented using property-based testing. You would just need to generate a random model for your view, use it to fill up your view, and then iterate over the subviews and check that every pair of subviews does not overlap each other. And just by doing this, you've implemented some kind of UI testing, and it didn't cost you a lot, and it was much more simpler to do than writing your full-fledged UI test. So thank you to a fellow French iOS developer for this trick, because I didn't come up with it, and it's very clever. So when is this approach relevant? When is property-based testing relevant in your app? Basically, every single time you have some external data, it's interesting, because external data, it's hard to anticipate what we're going to get, and property-based testing lets you kind of approximate all the crazy range of data that your code can be fed. When you have encoding and decoding, it's something that works very well, because there is a property which is that if you encode and decode, you must get back to the original value, so property-based testing is super efficient there. We also saw that for testing regular expression, it's a powerful tool to find edge cases we wouldn't have thought of when we looked at a complex regular expression. If you do custom sorting algorithm also, if you have arithmetic on time zone and dates, this is really a domain where edge cases, surprising edge cases can happen. It can help you. And of course, if you do SDK development, you know that developers and their apps are going to feed some crazy data to your SDK. It's hard to anticipate, so property-based testing can also help you get a lot of random data through your SDK in your test, and this way you can have confidence that in the real world your SDK is going to hold up. And finally, you might be thinking, okay, this is interesting, but still it's a lot if you want to put it in your app. Is there a lighter approach to get you started? And there is. So in Swift, you already have ways to generate random data for types like int, strings, etc. You also have libraries out there, open source libraries like Filetree, that are going to generate more business-like random data, like first names, sentences, addresses, phone number, etc. And then you can just write an extension on exit test case. It's an extension where you would have a function called fuzz, because sometimes it's called fuzzy testing, where you would pass it a test, and it's going to just try and run your test 100 times. And the idea is that in your test, you are going to use random data, and this way, your test is going to get run several times using random data. And if one of the data that has been randomly generated make your test fail, you will get a test fail report, and you will be able to fix the bug and basically make your app a little bit better. So, to conclude, some of you might know this movie. It got out a few years ago, Interstellar, and there is an interesting quote in this movie, is that a character say Murphy's Law doesn't mean that something bad will happen. What it means is that whatever can happen will happen. And it's kind of the same thing with our apps. We can think that, okay, this is never going to happen in production, but then when we look at crash reports, we see that crazy things do happen in production. So we cannot test for all the infinite number of data that our app can be fed, but using techniques like property-based testing, we are able to approximate this infinite number of data by generating random points everywhere in our data set. And basically, this is going to help us anticipate the complexity of the real world and get a better sense that our app is up to the task for the real world. Thank you for your attention.
Okay, we're going to do one question or two quick questions. If anybody has a question, raise your hand and you'll be handed a microphone. There we have one.
Hello, thank you very much for the talk. It was really good. My question is about composition of these properties. Like if you explore how to build up composing different properties that could build up like a different notion of, or compose a new property, is something like that is possible?
So you mean if you can compose property together?
Yeah, so if you satisfy maybe more than one property, you can say that that will represent another property?
Oh, okay. So yeah, you have operators to compose property. Yeah, because basically when you have a very complex property, it makes sense to break it down. Like for instance, when we said we want to check that the array reversal went well, we first need to get an index. So we get the index, and then we define another property that uses the index. So you can compose them this way in order like to build up more argument for the real properties. When it comes to composing properties together, basically the framework does it for you in a kind of way, because when it runs all the properties, it's like doing an end of all your properties, because you're asserting that every one of them is satisfied. I hope this answers your question. Yeah.
Okay, great. You can catch up with Vicent tomorrow or later today if you have any more questions. So
yeah, please do.
Thank you, Vicent.